stylus. So lots of people doing this perfectly. We're going to decide a parallelogram. A parallelogram has 4 congruent sides. That's the P. Then it is a rhombus. That's the Q. And a parallelogram is a square. So I see the word parallelogram, but I haven't seen the word square before, so I'm going to use a new variable. This is going to be R. Then it has 4 congruent sides. I've got the 4 congruent sides up here. I've already used that term, so I'm going to replace that with that same P variable. If I have a beginning and an end that match, they cross out, and then the R comes down, and the Q comes down. So my prediction for this last sentence is that R, a parallelogram is a square, and it says a parallelogram is a square, so that works out. Then it has my Q, then it is a rhombus. So then it is a rhombus. Then it is a rhombus, right? So that's the Q, and that works out. So this is valid, and this is syllogism. I wish I knew that Pear Deck existed back when we started class and we're doing these, because this would have made life so much easier if we just taught it this way from the beginning. But alas, that wasn't our lot in life. B is the midpoint. This geometry stuff is so important to read. So B is the midpoint. I'm going to predict that the endpoint is somewhere over here. So now I got to figure out what it is. A couple of different strategies to do that. X plus X divided by 2, Y plus Y divided by 2 is probably the easiest one. So I take my X's and I add them up. -4 plus 2 divided by 2 is going to be -2 divided by 2 is -1. And then my Y's 3 and 0, so 3 plus 0 divided by 2 is 1 and 1/2, right? Did I do that right? Somehow I feel like I didn't do that right. Oh, because I just found the midpoint. I just found the midpoint. That's the question on the next slide. Guys, you got to keep me straight. Need a new color. So really what I want to do is make this table. I've got -4 and 3 and 2 and 0. I got to add 6. So if I add 6, I end up at 8. And I add 3, so I end up at 3. I'm subtracting 3, -3. So 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. And that is pretty much where I predicted it to be, right? This, my friends, is the other endpoint. That is the answer to this question. That first thing I did, answer this question, determine the midpoint between A and B. So for this one, I'm going to predict that it's somewhere in here, and that was the answer I got on the last slide, 1, -1.5 by averaging. Okay, so 2 very different questions. Most people read perfectly, better than me, in fact, right? So know that this is not the answer to this question. The 8, -3 is. Okay, questions on that? Most people did that beautifully. So the third question I can ask with all of this nonsense, keeping all of these X and Y straight, is the distance. We can do distance with the face. X minus X squared plus Y minus Y squared. Put in your X's and your Y's. Make sure that you get your X's together. So -4 minus 2 squared and 3 minus 0. 3 minus 0 squared. -4 minus 2 is -6. If you forget to put that in parentheses, you're going to get a -36. You do definitely need a positive 36 here. And then plus 3 minus 0 is going to give me 3 squared, which is going to give me 9, square root of 45. Okay. The most common error that I see typically is this number, Somehow you get a negative 36 and then it doesn't work, or you get a negative 9, depending on how you do it. Any number squared is going to be a positive solution. Okay. The other way to do this is on the graph. So if I just make my slope triangle is 3 tall and 6 wide. So that green is very hard to see. 3 squared plus 6 squared equals c squared. You just take the square root and voila, you have the same answer. So Pythagorean theorem or the face, it doesn't matter which. You just got to choose one. This one, done, done, done. Counterexamples. When I want a counterexample, I want you to think counter conclusion. Where's the conclusion of the sentence? At the beginning or the end? Somebody say the end. The end. So I want to keep the beginning. I want a quadrilateral, but I do not want 4 right angles. Not 4 right angles. That's the counterexample or counter conclusion. So is a square a quadrilateral? Yes. Does it have 4 right angles? So that is not a counter conclusion. That is not a counterexample because I want not 4 right angles. What about a rectangle? Is it a quadrilateral? Does it have 4 sides? Rectangles, 4 sides? Somebody say yes. Yes. Does it have 4 right angles? Yeah, rectangles have 4 right angles. If you're not sure, draw one. You know what a rectangle looks like. 4 right angles. So that is also not a counterexample because we are looking for not 4 right angles. What about a trapezoid? Is it a quadrilateral? Does it have 4 sides? Yeah. Does it have 4 right angles? No. It does not. My friends, that is our counterexample. Counterexample, counter conclusion. Keep the beginning. I want a quadrilateral. So a triangle won't work, a pentagon won't work, a hexagon won't work. It needs to have 4 sides, but I want something without 4 right angles. Could a rhombus have worked? What's a rhombus look like? Rhombus has 4 equal sides, but it's got 2 acute angles and 2 obtuse angles. So a rhombus would be a counterexample. Okay. Then I think we've got one more. One more. We save the best for last. If we reflect over the line y equals x, what is the rule? If I reflect over y equals x, what do I do to those ordered pairs? Somebody say flip them. Flip them. You have to say it out loud so I can hear, by the way. So if I have an x of -4, that becomes the y. And if I have an x of 3, that becomes, or a y of 3, that becomes the x. We just flip them. What if I reflect over y equals -x? What do I do with those? Flip and negate. So we're going to flip these and negate them because of that little negative sign right there. So the 0 can't be negative. I just flip it and keep it 0, but the 2 can become negative. Okay? So y equals x, you just flip. It's like the converse. And y equals -x, you flip and negate like the inverse or like the contrapositive. Okay?